Hello, we have a 2008 BMW 328xi. We made a video about a thermostat testing a couple of days back. Now we removed the thermostat and found an interesting thing. The thermostat actually was not stuck open and it was operating properly. So we put the thermostat back in and started thinking about what could be causing that. Now we found this. The radiator in this car is actually made out of two pieces. The lower part of the radiator is designated for transmission cooling, and it's not supposed to be connected to the upper part of the radiator. Apparently we have an internal leak inside the radiator, which is causing the cold fluid go into the engine block. Now, to test that, you have to do the following steps. Well, you're testing it like you're testing for the thermostat, just like we did in the previous video. If you see that the temperature of the engine is actually not reaching the operating temperature and the outlet hose is around 130 120 degrees when the thermostat is closed, that means it's either you have the same internal leak in the radiator or your thermostat is actually stuck open. Now if you look down deep on the right side of the radiator, there is a lower radiator hose with a coolant temperature sensor attached to it. And below that, this little hose over here is also attached to the radiator. Now this is the outlet from the transmission cooler, and if you follow that hose up, it's connected to that metal pipe on the side of the block, which is going straight into the block. So that is why our car was undercooling and the heater was not working, just because there is a leak inside the radiator causing the cold fluid to go into that hose and go into the block. Now to test that, start the car up, warm it up to proper temperature, check with the scan tool, make sure that it's actually at proper temperature, and start driving. You see your car cooling down, go out and pinch this hose. Do not leave it pinched, because if the weather gets warmer you might damage your transmission. So pinch that hose just for testing purposes and see if your actual engine temperature is gonna go up to around 200 degrees Fahrenheit, and the coolant temperature and the radiator outlet should be around under 100 degrees or 100 degrees Fahrenheit. And then when the thermostat starts opening, that's when the temperature in the engine is going to be dropping and the temperature in the outlet hose is going to be going up. Now we see the temperature is getting up to the approximately normal operating temperature. You could let it ride or give it a little bit of gas, about 2000 RPMs, keep it there to make sure it gets to around 190, and then take it for a ride and check the temperature readings. Well, we didn't do anything yet, we're just showing it what the readings are. As I said before, we determined that the thermostat is not stuck open, therefore we're testing the rest of it. Now we got to 190, take it for a ride, maybe a 5-minute ride, and see what it's going to be showing. Have your heat on. You see the temperature is going down little by little. And the faster you go, the lower the temperature is going to get. Well, it became a little bit warmer outside, so it takes a little longer for it to actually show the results. get the idea. The outlet temperature, the radiator outlet temperature is going up. The engine temperature is going down, which under most of the times that's the sign that the thermostat is stuck open. Well, like I said before, we checked our thermostat and it's actually not stuck open. That is why we're doing the rest of the testing. So yeah, the temperature is hovering at around 172 degrees Fahrenheit. Well, right now it's pretty warm outside, so it's probably not gonna go much lower than that unless you get on the highway. At highway speeds of maybe 60-70 miles an hour, probably gonna go a lot lower than that. But right now the temperature should be at around 200 degrees. So we definitely know that the engine is undercooling, like overcooling. Yeah, see, we turn on the heat on high, and the temperature started dropping even more. So now what we're gonna do is, just for diagnostics purposes, do not use this as a fix for your heater problem. You will damage your transmission. Do not leave the clamps on the hose permanently. See this hose over here, the lower one? You gotta follow it. It's gotta be going to the bottom of the radiator. See right there? You follow that hose. Make sure you pinch off the right hose. So we're gonna pinch this hose off. So to pinch off this hose, we use this hose pinch tool. You should not be using any vice grips. You could damage the hose easily with the vice grips. So we're gonna pinch the hose off, make sure it's pinched off, and take it for a ride again and watch the temperatures again. Make sure when you put the pinch pliers on the hose, they don't get caught in the radiator fan or the belts or anywhere else. Use caution, a lot of it. If anything gets caught on the belt while you're driving, it will cause tremendous amount of damage to the radiator fan, radiator itself, and surroundings. So make sure it does not get caught on the radiator. You might even want to secure it somehow so it doesn't get caught on any moving parts. Now we restarted the car. We still have the heat blasting. I'm gonna bring the RPMs up to around 2000 and see what's gonna happen with the temperatures. Okay, we have the temperature going up, just like we had without the pinch pliers. However, it's going up a lot faster than it used to, even though the heat is blowing on high. Okay, so it's around 190 degrees Fahrenheit. Let's take it for a ride and see what happens. We see actually really good results. The temperature got up to the point where it didn't go up before we put the pinch pliers on. Our heat is blowing real hot air, just like it should be. This is the exact temperatures it should be at when the car is fully warmed up. Alright, so I guess the outside temperature is pretty low for the radiator to be able to cool off the coolant that much. So we're gonna turn down the heater blower so the engine gets a little more temperature in it. But we do see that the actual engine temperature is hovering around 205, 204 degrees, which is perfect. Now we turn the heat down. We're watching the temperature, and the engine temperature stays perfectly where it's supposed to be. The heat is hot, working fine. So that just proves that the radiator actually has internal leak into the transmission part of the radiator. Now the lower the radiator outlet temperature doesn't really go up much, but I guess it's just because the temperature outside is pretty cool, so it's sufficient enough to cool down the coolant to that point. So here you go. We have a new radiator, nice and original. I'd suggest you use original radiator. Now, this is the hose that we pinched off in the car. This is the right side of the radiator. This is a hose that goes to the thermostat. This is the hose that goes to the engine block. Now on the other side over here is a fitting for a transmission cooler. This part of the radiator is separate from the rest of the radiator. It's not connected. So in our case what we have is it's leaking internally in either of the banks. One of the banks, and causing the engine to overcool. Now this is updated radiator. This is the updated radiator drain plug. It's one-time use. Once you put it in, you will break it while taking it out, so don't put it in and try to take it out. If you need to drain the coolant, you need to use this screw. In older radiators they have a bigger drain plug which unscrews, and it has this long tube with the O-rings on each end of them. Now before you replace the radiator, take this drain plug out and make sure this piece is intact and all the seals are intact, because this might be the cause of the actual leak. We took ours out, it's not, so we're gonna be replacing the radiator. Now one more thing about this radiator, there are two types. It could be just a white radiator without this sensor over here. This is called the Ozone Sensor. This brown coating on the radiator makes this radiator a lot more expensive than a regular one. So make sure you do not try to take the sensor off. It's a security feature in the sensor. If you try to take it off, it's 100% gonna be throwing a check engine light on saying that the ozone sensor is bad. Do not try to take this part off. It comes with the radiator, comes pre-installed. Do not take it off. You cannot buy it separate. This is meant just for emissions purposes, for this coating. Those cars that came with this radiator, the sensor is telling the computer that if it's a right or wrong radiator installed in there. Do not take the sensor off. There you go.